Welcome everyone. All right, looking at the question here, the power in a mechanical device is given by a formula which is P equals AN plus B over N. A and B are constants. And now we are going to use Cramer's rule to determine the values of A and B if P equals 13 when N is 3. Now let's start from there. If P is 13 and N is 3, let's substitute. Substituting for P, we shall have 13 equals AN, so A into 3 plus B over N, which is 3. Okay, I can decide to multiply everything by 3, so that 3 times 13 gives me 39 equals 3 times A times 3, that is 9A, plus B over 3 times 3 is B. Now rearranging this equation, I shall have 9A plus B equals 39. The question continues by saying P is 12 when N is 2. So P is 12 when N is 2. Again, substituting, I shall have 12 equals A into 2 plus B over 2. And then of course multiply through by 2, from which 2 by 12, that is 24, equals 2 by that one is 4A plus B over 2 times 2 is B, implying that 4A plus B equals 24. Now I can call the first one here equation 1 and this one equation 2, and these are a pair of simultaneous equations. So my equation 1 is 9A plus B equals 39 and 4A plus B equal 24. Equation 1, equation 2. Using Cramer's rule now, what does Cramer's rule state? Cramer's rule states that if you have a pair of simultaneous equations of the form x1a plus y1b equals z1 and x2a plus y2b equals z2, then your value of A will be A1 over A and B equals A2 over A, where A is the determinant of the matrix coefficients of A and B, that is x1, x2, y1, y2. A1 equals the determinant of the matrix when the coefficients of A are replaced by the right side, hand side of the equal values, that is Z1, Z2, Y1, Y2. So Y1, Y2 stays. Then A2 is the determinant of the matrix when the coefficients of B are replaced by the right hand side of the equal values. So we have x1, x2, z1, z2. So x1, x2 in this case, they stay. Now comparing the two values, the values from my Cramer's rule and the values of the pair of simultaneous equations, they are more or less the same, because the coefficients of A from my equation 1 and 2, we can say that x1 corresponds to 9 and x2 corresponds to 4, y1 corresponds to 1 and y2 also corresponds to 1 coefficients of b. Now, from there you can go ahead get the value of a, which is the determinant of the matrix or the determinant of the matrix coefficients, that is x1, x2, that is replaced by 9, 4, and then y1, y2, that is 1 and 1, from which the determinant, as always, take 9 times 1, subtract 1 times 4, which will give you a value of 5, because 9 minus 4 is 5. A1, on the other hand, will be the determinant of this matrix. Now, the coefficients of A are replaced by the right hand side of the equal values, and from my pair of simultaneous equations, those values are 39 and 24, and then the y1 and y2, those values, the coefficients of B stay, so that is 1 and 1, from which we shall have 39 times 1, the determinant, minus 1 times 24. That gives me 39 minus 24, which is 15. A2 is now the matrix of the determinant, I mean, of this matrix here, x1, x2, and x1, x2 corresponds to 9, 4, and then z1, z2, that is 39, 24, from which the determinant becomes 9 times 24 minus 39 times 4, which is the same as 216 minus 156, which gives a difference of 60. So that gives a difference of 60. Now, from there you can just go ahead and get the values of A and B. So A is given by A1 divided by A capital. So that is the A1 was 15 and A is 5. And that gives me a value of 3. And the value of B equals A2 over A, which equals 60 divided by 5, and that is 12. So A is 3 and B is 12. This is how you go about solving such kind of a problem. And if you are still watching this video, that means you like the video. So please hit the like button, share this video with your friends, subscribe to my YouTube channel, give your feedback under the comments section. Otherwise, thank you all for now.